In this part of the video, we're going to talk about writing the equation when we have some information. Let's say we had this equation, y is equal to a bracket x minus 3 times x minus 5, and another point of negative 230 on the parabola. Similar to what we did when we were in standard and vertex form, we're able to substitute in the x and y and use algebra to solve for the a. So we know that negative 2 and 30 is a coordinate, meaning it's represented by an x and the corresponding y. We're going to sub that point into the partial equation. So now we have 30 is equal to a times negative 2 minus 3 and negative 2 plus 5. 30 is equal to a times negative 5 times positive 3. 30 is equal to negative 15a, and we're going to divide both sides by negative 15. So a is equal to negative 2, and the equation, or the full equation, is negative 2 times x minus 3 times x minus 5. Okay, the next example, we have a parabola with the zeros of negative 2 and 4 and a y-intercept of 4. Sketch it and find the equation. Right, first of all, let's do a quick sketch. I know that at negative 2, we have an x-intercept, and at positive 4, we also have an x-intercept. We also know that at 0, 4, we have a y-intercept. Now, even though I don't know exactly what the graph looks like, my guess is that it's going to be a parabola that opens down. So we have some value of a that's negative. Now, we don't have a partial equation, so we're going to develop the partial equation on our own. We're going to go backwards to using our x-intercepts to put it into factored form. Now, we know that when we're solving, we got x is equal to 4. So for me to rearrange it into the bracket, I need to rearrange it so that I have a first bracket where it's equal to 0. And so one bracket is going to be x minus 4. Our second one here, we're going to do the same thing. We know that x is equal to negative 2. So when we rearrange it, we have x plus 2 is equal to 0. And here's our other bracket. The 0, 4 is going to be the other point that I use to substitute into my equation. So let's write the partial equation now. Y is equal to a times x plus 2 times x minus 4. And I got these brackets based on our x-intercepts. Next, I'm going to substitute in my y-intercept because that's a point on the graph. So when I substitute it in, we would have 4 is equal to a times 0 plus 2 times 0 minus 4. We have 4 is equal to a times 2 times negative 4, and 4 is equal to negative 8a. Let's divide both sides by negative 8. And we have an a value of half, negative half. And our full equation now, y is equal to negative half times x plus 2 times x minus 4. Let's do one more example. We have a parabola where the zeros are negative 5 and 3, and a maximum or optimal value of 6. A maximum value means that this is our vertex. We only know the y-coordinate because the y-coordinate can tell us the maximum. So we need to know the x-coordinate of our vertex. So let's find the axis of symmetry. We have negative 5 plus 3 divided by 2. X is equal to negative 2 over 2. And x is equal to negative 1. So our axis of symmetry, x is equal to negative 1. We also know that this is the x-coordinate of the vertex. So we know that the vertex is negative 1 and positive 6. As for the x-intercepts, we know that for one of them, x is equal to 5. So when we rearrange it, we have x plus 5, that's our one bracket. And for the second one, x is equal to 3, x minus 3 is equal to 0. Our partial equation now, y is equal to a times x plus 5 and x minus 3. Let's substitute in our vertex. So we have 6 equals a times negative 1 plus 5, negative 1 minus 3. 6 equals a times 4 times negative 4. 6 equals negative 16a. 6 divided by negative 16 is equal to a, and we have a is negative 3 over 13. So coming back to our equation, we can substitute negative 3 and 13 into that, and we have our full equation now. There's a few practice questions for you to work on. Pause the video to do this, and I will come back with the solutions. Here are the solutions to the questions that you're asked to try on your own.